Hi, welcome to the video lecture on Small Signal Analysis of Common Collector Amplifier Part 1. In this video, we are going to see about the analysis of Common Collector Amplifier and derive the expression for small signal voltage gain AV, and finally we are going to derive an expression for the input resistance Ri. So now let us look at the general common collector amplifier circuit. It consists of an AC input voltage Vs to which this internal source resistance Rs is attached, and it is connected directly to the base using this coupling capacitor Cc, where R1 and R2 are the voltage divider biasing resistances, and plus Vcc is the externally supplied biasing voltage which is connected to the collector, and Re is the emitter resistance, and the output voltage V0 is taken from the emitter. Now when you look at the circuit, you could see the collector is connected directly to the Vcc. Okay, so it is connected directly to Vcc, and the output signal taken at emitter with respect to ground. Since the output voltage follows the emitter terminal, this common collector is also known as emitter follower circuit. Now let us look at the small signal equivalent circuit of this emitter follower. So it consists of this base where the input signal is given to the base and the output is taken from the emitter, and the collector terminal is made common, that is, it is grounded. So between the base and emitter you have got this R pi, which is the diffusion resistance or the base emitter resistance, and between the collector and emitter you've got this internal dependent current source, that is beta IB, and R naught, which is nothing but the early effect resistance. Okay, so you have got this Vs, Rs, the Cc coupling capacitor alone is short circuited, and RTH is nothing but R1 parallel R2, and Vin is the input voltage across this RTH. So you could see the small signal equivalent circuit of the emitter follower, which is shown here, and the output is taken at the emitter terminal. Now we can draw this circuit into another form of small signal equivalent circuit. That is, you can bring this ground collector terminal and connect it at the same point. See, rearrange the previous circuit so that all the signal grounds connected at same point, so that you will get the circuit like this. That is, between base and emitter R pi is connected, and from the collector to the emitter the current source arrow mark has to be drawn correctly, beta IB. Then you have to mark this Ri, RIB, which is the internal resistance. This is the internal resistance with respect to base, and this is the output resistance. So input is given to base, output is taken from the emitter, and finally the collector terminal is grounded. So now let us see the expressions for the small signal voltage gain AV. So when you look at this, you could see what is I naught. By just applying KCL, you get I naught as 1 plus beta into IB. The output voltage is written as V naught is equal to I into R. What is that I? I naught into R naught parallel RE. You know already I naught, substitute here. Next, apply KVL around base emitter loop. Okay, so if you apply KVL, you get this expression of Vn. So when you bring this IB towards this side, you get Vn by IB, which is nothing but RIB. So this is the expression for the internal resistance with respect to base. Finally, we can apply voltage division rule and get the expression of Vn. That is, total voltage Vs into same branch resistance Ri divided by total resistance, that is Ri plus Rs, is the voltage division rule applied here. You can get the expression of Vs from this. So where Ri is nothing but R1 parallel R2 parallel RIB. So combining all these expressions, we get the expression of AV as V0 by Vs. So you can get the expression of V0 from here. You can get the expression of Vs from here and write the final expression of AV. So finally, you can see the input resistance expression which we have already derived, that is RIB is equal to Vn by IB, which is equal to R pi plus 1 plus beta into R naught parallel RE. Okay, since IE is 1 plus beta times IB, the effective impedance in emitter is multiplied by 1 plus beta. So this multiplication is known as resistance reflection rule. Okay, so by watching this video, I hope you would have clearly understood about the analysis of common collector amplifier and the derivation of this small signal voltage gain and input resistance. Thanks for watching.